relative max right there.
Okay,
It's
yeah.
kind of like when you hike. I don't know if you've ever been hiking, but sometimes you get to a place where you're higher than everywhere else. But
Mm-hmm.
you look up and you're like, oh, well, I'm not, this isn't Mount Everest. I'm not at the top. So, um, you
Yeah,
realize, okay, it's higher than everywhere else, but it's not the highest.
yeah,
Okay. And then if you keep traversing the curve here and you go to the right, well, you're going to the right and you hit a valley. You hit a valley down here. You can think of these as peaks and valleys. There's a country music song about that, probably. And this is a relative min. So again, it's like, well, not the lowest. I mean, I was, down here on ground level, and I'm just lower than where I was.
okay.
Okay. Um, and then you go up, rise forever. Okay. So that's kind of the like if they asked you to describe the graph, you could give a description like that. So we should go through this where we give definitions of each thing. So x-intercepts cross or touch the x-axis.
Yeah.
Can you give me the x-intercepts here, please?
1, 0,
Okay.
-4, 0, and 6, 0.
All right. Now there could be one, two, three, four. There could be a lot. There actually could be none, depending on the graph. Okay.
Okay.
So there's no like rule for that. It's just where it crosses or touches the x-axis. Is that okay?
Yeah.
All right. So it's more important that you know the definition than it is the actual points because you're going to get a different graph, or I'm going to give you a different graph. So the y-intercept is where it crosses. It always crosses. Well, actually, I take that back. It could touch, but typically crosses the y-axis. And there's typically only one. There could be none, but what is the y-intercept here?
Um, it's 0, 24.
Yeah, you've already gotten that down, so you're already in good shape.
Yeah.
Okay. All right, now we're going to do some other stuff here, and you kind of already have we've already kind of identified those, but um, we'll do this out of order. Um, your teacher is using relative slash local min, and that's always uh, an ordered pair, relative slash local max, and that's always an ordered pair. So it's minus 1.9 comma 48.1, 3.9 comma minus 48.1. And you could have more than one. Like there's no like rule here, but the mins kind of come down like that. Maxes come up like that. Is that okay? Clear?
Yeah.
All right. So now this is the hard part. The next stuff is the much more difficult stuff, where it's increasing and decreasing. So increasing, another definition, the graph is going up and to the right, up and to the right. So there's the two dots that I'm going to draw on here for the relative min, relative max. Now I'm going to shade. So this yellow line here and this yellow here is where it's increasing. Do you agree that the graph is going up and to the right?
Yes.
Okay, now it's only the x values. Do not care about y. Write that either. Do not care about y. So you have to think about this. I know this graph is going down forever, but how far left is it going?
Infinity.
Negative infinity, yeah.
Negative
So from
infinity.
negative infinity to negative 1.9, notice that's the x value. That's the x value at the red dot.
Okay.
It's increasing.
Okay.
All right, now it's also increasing over here on the right. where the second yellow is.
Yeah,
Okay, so what is the leftmost x value there where it's increasing?
3.9.
3.9. Okay. And then how far to the right does the graph go?
Positive infinity.
Positive infinity.
Wait, hold on though. Why wouldn't the negative 1.9 be out in front?
So it's always from left to right.
Oh, okay.
So the better way to do this, which I guess they don't do in this course, but is to actually build like a number line here, where I put the red dots there and there. And we label this. So it's increasing here and increasing here.
Okay.
You agree with that? And do you see how I
Yeah.
came up with that? Okay. You can do this. This number line is a good strategy. It's actually used in calculus. Um, you can use it here. It's not like do with anything,
Okay.
but you have to kind of decide what you want to do, how you want to remember this. But the most important thing is to remember that increasing is up and to the right, up and to the right. Second thing is it's the x values. I never want to see a y value here. Never, 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 never.
Is this the interval?
Yes,
The increasing
that's
interval?
the
Okay.
yeah, that's the answer. So just to be clear, everything in this blue box I'm about to draw, this is your answer. Everything else leads to that answer.
Okay.
This is the most difficult thing, so we're going to do a bunch of these, of course. Any questions on this?
No, I think I get it.
Okay, now we're going to do decreasing. Decreasing is where you're going down and to the right, down and to the right. So again, you label the min, the max. I'll shade it in a different color this time. Green. Everyone likes green. Color of money.
Mhm.
All right. Now, again, you only care about the x values. You do not care about y. Sounds mean, but y is not important. So you could again make this number line here. Label the two x values or however many there are. There could be more than one. And label where it's decreasing. And it's always from left to right. So from minus 1.9 to 3.9.
Okay. That's it.
That's it.
All right.
So good time to ask me some questions because I want us to do a few problems where we just focus on increasing and decreasing.
Okay.
If you have any, you don't have to. Maybe we'll come out of doing some questions.
No, I think I'm good. I just need to see this. Like,
We're
wait,
gonna do a
hold on.
couple examples. I mean, you're not on an island here.
Okay.
All right, let
Hang
me
on.
go to my graph here. All right, so actually I'll make this really similar to what we just did. Just to practice. Right. So here's your problem. I want
Okay.
you to tell me where it's increasing and decreasing.
Does it just go into infinity?
Yeah, it goes up. They both consider them both going up forever, down forever. Like that. It's really, really similar to the last one.
Okay,
Different
yeah.
numbers.
Okay, for increasing, uh, one, I don't know how you'd say it, 1 point or one like, I don't
Well, let's
know.
go back and look at the answer to the previous one.
Well, I know how to do it. I'm just saying like how do
What
you
is
like, yeah.
so you say from minus
Uh-huh.
infinity to minus 1.9
Okay.
and from 3.9 to infinity.
Okay. From negative infinity to negative 0.786 and from 2.12 to infinity.
Okay. And where is it decreasing?
Um, negative from negative 0.786 to 2.12.
Very good. Let's throw in another wrinkle here. Domain and range. These are both all real numbers. Minus infinity to infinity. Not sure why they're testing that here, but they are. Oh, right.
The domain and range are kind of like I kind of get confused by that.
For now, let's just go with they're always this.
Okay.
For now, like I'll see if if you send me something that says they're different, we'll look at that. But okay, you ready to do another problem?
Yeah.
Okay, this one's different. This is new. These go down forever. I want you to tell me where it's increasing and where it's decreasing.
Okay. Increasing from negative infinity to negative 3.871
Okay.
and from I think from negative 0.562 to 2.183.
Okay, good. Now where's it decreasing?
Um, from negative 3.871 to negative 0.562
Okay,
and from 2.183 to negative infinity.
okay. Now, negative infinity though, you're giving me the y value here. How far to the right does this go?
Um, well, it goes right infinity.
Right. So it's positive infinity, the x values. It's very easy
Okay.
to do what you just did here. That's why sometimes it's good to make that number line and put minus infinity and infinity here.
Okay. Yeah.
Totally up to you.
Okay.
Okay. Okay. So when I ask you for the domain, oops, let me do that in red. When I ask you for the domain, what I'm really asking you is how far left, how far right.
Okay.
So how far left does this graph go? I know it goes down forever and down together, but how far left does it go?
Uh, left infinity.
Okay. Negative infinity.
Yeah.
How far right does it go?
Uh, positive infinity.
Very good.
Is that it?
That's it. Now the range is a little bit different. It's another set of questions, but the range is how far down, how far down how far up? You can think of down as the min, how far up is the max. So basically, how far down does it go?
Negative infinity.
Negative infinity. Now, this isn't different. This one does not go up forever, right?
Yeah.
It's so what is the biggest y value? The biggest y value.
70.698.
There's your range.
Huh. Okay. I get it.
All right, let me give you a new problem here. All right. I want increasing and decreasing again.
Okay. Um, huh. Increasing from negative 1.528 to 1.528. Huh.
Don't think too
And
much about it. Just do what we've been doing.
and then the other two would be decreasing, right?
Well, you tell me. What does it mean for it to be decreasing? What is the definition that we wrote down?
Um, I'm not sure.
Okay, let's go back and look.
All right, down.
All right, here we go.
Down slash right. Okay. Down. Okay. Yeah, okay. So the first decreasing would be from negative infinity to 1.528. And then from
Okay.
1.528
Okay.
to negative infinity.
Going to the right forever. Negative infinity is over here. So to the right forever is,
Positive infinity.
yeah, it's the x values.
Okay, so it would be positive infinity, but it would still be decreasing. Okay.
Yeah. Yep. Yep.
Okay.
Okay. Now let's talk about domain and range.
Right.
All right. So domain, what you're thinking about here is how far left, how far right, how far left does this go?
Negative infinity.
Okay, and how far right does it go?
Positive infinity.
Range, how far down does it go?
Negative infinity.
How far up does it go?
1 point. Oh, wait, no, it's the Y. 26.257.
So you're saying it's never bigger than that value.
Oh, okay. So it could, oh, yeah, right. So,
What about all these points? So how
which
far
one?
up does it go?
Um, infinity.
Yeah.
Okay.
All right. Now this point I'm going to call point A and point B. Which is the min, relative min, which is the relative max?
A is the relative min, B is the relative max.
Okay, good. All right. You're doing pretty well.
E.
I'm going to give you another problem here.
All right.
this graph goes up forever. All right, so I want you to tell me where it's increasing and where it's decreasing, please.
Okay.
I'm sorry, and you do need one more point here. I didn't label this point, but there's that point there. 4 comma 0.
Okay. Um. So one decreasing is negative infinity to 0.
Okay.
And the increasing would be from 0 to 2.75.
Okay.
And then a decreasing from 2.75 to 4.
Okay.
And the last increasing from 4 to positive infinity.
Good. All right. So let's talk about points A, B, and C, which are relative min, which are relative max.
Um, B is the relative max, A is the relative min.
So what did C?
Well, I was gonna say irrelevant, but
Again, just think about that hiking analogy. You're up at B, but then you walk down into a valley. Think about where you are relative to your surroundings.
I would say relative min.
Yes. Now you can have more than one.
I did not
Maybe
know
that
that.
maybe that was unclear. Yeah.
Yeah. Hmm.
All
Okay.
right. Now we'll talk about domain and range.
Okay.
How far left does it go? How far right does it go?
So negative infinity, comma, positive infinity.
Good.
And then
What's the smallest y value?
uh negative wait.
Range is always the y's.
Okay. Yeah, so it would be -8 comma infinity, right?
Yes. A small little wrinkle is that you put a bracket around the -8 because
Uh,
it's included
included in what? Was it?
in the range. So parentheses doesn't mean that it's included. I avoided discussing it in a previous problem. It's a lot of little, tiny little stuff. If you don't like that, just put parentheses.
Hmm. Okay. All right.
It's like in basketball, if your foot's on the line, it's on the line, right? You can go right up to, but you can't be on the line.
Yeah.
Here, we're saying you can be on the line,
Okay.
right? Feel like you understand this. Do you have something else that you would like us to work on today?
Yeah, let me. It's kind of weird that that was all he gave us as a review because I feel like there's kind of been maybe a few more things that we.
Yeah, I mean it's stapled. Is there not a third page or something?
No, it's the same. It's the same stuff. It's just yeah. There's like the last page is just it's still asking for all the same stuff. It's just like a very slightly different graph. It's like kind of a U shape
I see.
over the X, but I feel like there's still like this is weird. There's gotta be more stuff than
Absolutely,
I
yeah.
mean, the thing. Yeah, the thing is he's probably gonna give us because to tomorrow and Tuesday are just like review days in class. So
Okay, well, I can go give you some review stuff as well.
okay, if you can think of something.
Try to keep it specific to what you guys have been working on here.
Okay.
Okay, let's do a little bit of solving. This one says to solve by factoring, but you can actually do it a couple of ways. There's actually two types of factoring you could do here, or you can use the square root property. Do you remember anything about how to solve something like this?
Um, just add 100 to the other side.
Okay,
Um, and then you find, yeah, you find like the square root, and
okay,
then x equals 10, right?
kind of. I graph this for you.
Yeah, I'm kind of remembering this a little bit.
So you also did this at some point. You graphed the equation. This is y equals x squared. Do you remember that? U shape.
Yeah,
And then this is the line y equals 100. How many times does it hit the parabola?
twice,
Okay. How many answers did you give me?
just one.
When you take the square root, it's plus or minus the square root of 100.
-10.
Yeah.
Yeah. Okay.
Whoops. So make sure you give two answers.
Okay.
So sometimes the problems are disguised a little bit. It'll say, I don't know, like 64 minus x squared equals 0. Could you solve this for us, please? It's
Yeah.
very similar to the last.
Okay. Just, I guess you can add x squared.
Okay, I agree.
So, 64 equals x squared, and then so find the square root. So it would be 8 and -8.
Very good. Okay. The next type of factoring that you might see. Let me grab another snip. Problem numbers are way too close on these. Okay. Right. So next type of factoring is where you have three terms. Okay. And a is equal to 1. A is the number in front of x squared. You're looking for two numbers that multiply the 3 and add the -4.
Okay. Um, would be -1 and -3.
Okay. So you write x minus 1, x minus 3 equals 0. You remember what to do from here.
Wait. Um, what are we trying to find? I don't
You're trying to
really.
solve for x.
I mean, you can like that x minus like 1 minus 1 equals 0. Yeah.
You're setting each of the factors equal to 0.
Okay.
So go ahead and solve that for x, please.
Yeah. So 1 and 3.
X equals 1, x equals 3.
Okay.
That's your final answer. Final answer is you're literally solving for x,
Okay.
right? Your final answer should be like x equals something when you're done.
Hmm.
Is that okay?
Yeah.
All right, so here's another one for you to try. kind of the same type of problem. Go ahead and take a look at it. Be right back. Pick on you.
Okay. Um, let's see. -7 times 3.
Okay. So this time you're trying to find two numbers that multiply to -21, but add to -4.
Yeah. -7 times 3, right?
Okay. So what goes in parentheses here?
Uh, can you do x plus 7, x minus, oh wait. Yeah, sorry. Shoot, why did I just trick myself? X minus 7 times x minus x plus 3.
Okay, that does work. Keep going. Go ahead and solve this completely.
Um, set them both equal to 0, and then so x equals 7 and x equals -3.
Okay, very good. Any questions on that?
Nope.
Okay. Here is your last one to try. We'll switch to something else. Go ahead and solve this for us, please.
Um, let's see. Oh yeah, sorry. -2 times 2, or -2 times -2, and then so you do x minus 2 times x minus 2.
Yeah.
And then you would get, would you put it twice, or is it just x equals 2?
So both are right. It's considered a double root, but you only have to give one of the solutions.
Okay, x equals 2.
All right. Very good. Okay. So we're gonna look at some more quadratics here.
Okay.
So here we go. This is a little bit different. We're going to talk about graphing, how to graph something like this.
Mhm.
What is the vertex? First, determine the vertex. Remember that at all?
Yeah, honestly, I forget, man.
That's fine. You just got to say that. So I'll prompt you here. This is the formula. The vertex is h comma k.
Okay.
So can you tell me the vertex?
Yeah, -3, comma, -1.
Okay, so the k is correct, but the h is not. Notice that there's already a subtraction operator here. So it's just the number. Or what a lot of students remember is it's the opposite of what's inside parentheses.
Okay, so 3.
3. Okay. Tell me about the transformation here. What does this mean in terms of left, right, down?
3 right, 3 right, 1 down.
Right 3 or 3 right, down 1. Good. Okay. So the normal graph is here. Right 3, down 1. It looks something like that.
Okay.
Okay. We're going to do the same thing here for another problem, or 2 or 3. See how many we can get through. What is the vertex?
Um, that would be 1, comma, 2.
Your K is correct. First one is not.
What?
What did we say about that letter number inside parentheses?
Oh, you flip it.
Okay.
So -1.
So what are the transformations?
Left one down two.
Now, if I put a negative in front, do you remember what that does as far as a transformation?
It would make it positive.
It's a reflection. Do you remember which axis it's over?
The y-axis.
To the x-axis. So it
Okay.
goes from opening up to opening
Uh-huh.
down. Sometimes it's good to draw a picture.
Okay, yeah, yeah, yeah.
Really important, really, really important to draw a picture to just verify that kind of thing.
Okay.
Okay, here is a new problem for you to look at. All right, what is the vertex?
Um, +4, comma, -4.
Okay, and what are the transformations? There are three of them.
We have reflection over the x-axis, and then right 4, down 4.
Okay, very good. Could you try on your paper to sketch a quick graph of what you think this looks like?
Yeah. Okay. Okay.
All right, so here's kind of where what I see. It looks something like that.
Yeah.
Okay. Does this have an x-intercept? Does it cross the x-axis?
No.
No. Not everything does.
Well,
All right, let's look a little bit at piecewise graphs. I know you did a little bit of that at some point. Okay. How many pieces are there to this piecewise function?
um, pieces,
Yes.
maybe.
How many pieces?
I don't know, too.
Two. There's the first one and the second one. Before you answer these, I want you to tell me which piece you're using for each one.
Oh, okay. Yeah, I remember this a little bit.
This
F,
one's written a little awkwardly, so that's why I'm asking as well. It's a little bit different than what you saw in your class.
okay, F of 8 for number 1, and the rest are,
Uh, okay, so you're saying number one for this one, and the rest are number
number 2.
two.
Yeah.
Go ahead and calculate the first three for us, please.
Okay. Okay. I got, for number 13, I got -1. Number 14, I got 24. And then number 15, I got 5.
All correct. Very good. All right, so we'll keep kind of with our thinking on functions here a little bit. So here's a function. Okay, let's find f. Wants to calculate f of -2. As a reminder, put the variable in parentheses.
Okay. Um, This is kind of weird. Um, I got -14.
Okay, let's take a look. It's -2 squared plus 3 times -2 minus 4. So that's -4 minus 6 minus 4 is -14. Very good. All right. Let's have you find g of -3/2.
Okay. Ooh. Hmm. Um,
All right, so it's 2 times -3/2 plus 1. When you multiply fractions, you multiply the tops and then the bottoms. -3 plus 1 is -2. All right, we're going to stop there for today. Good job.